Hello, my name is Sheena Vickers and I'll be presenting on Buffer Overflow, the implementation bug. What is a bug? A bug is an implementation level software problem that may exist in code but never be executed. The most persuasive security problem today in terms of repeated bugs is the buffer overflow. What is a buffer overflow? A buffer overflow vulnerability condition exists when an application attempts to put more data in a buffer than it can hold. The program is writing beyond the end of a buffer or bounded array. Buffer overflow accounts for approximately 20% of all vulnerabilities found, categorized, and exploited. Buffer overflow has become synonymous with vulnerabilities or, in some cases, exploits. All buffer overflow are a product of poorly constructed software programs. They are considered dangerous since most of them allow attackers the ability to control computer memory space or inject and execute arbitrary code. Hackers usually exploit buffer overflow vulnerabilities to overwrite the content of adjacent memory blocks, causing data corruption, crashing the program, or executing an arbitrary malicious code. Buffer overflows create problems only for a native code, that is, programs which use processors' instruction set directly rather than through some intermediate form such as Java. The overflows are tied to the way the processor and the native programs manipulate memory. They exist because of the use or misuse of vulnerable APIs such as gets in C language. The buffer overflow problem exists because it is so easy to write beyond the bounds of data objects in languages like C and C++, unlike Java and C#, where definition of exactly what constitutes a data object is much more tightly controlled. In a buffer overflow attack, the attacker sends data to the application that stores in an undersized stack buffer that overwrites the information on the call stack. The attacker is then able to run its own malicious code once a legitimate function is completed and the control is transferred to the exploit code contained in the attacker's data. Buffer overflow can be detected through two general approaches, internal and external mechanism. The two main flavors of buffer overflow are those associated with stack allocated buffers and those associated with heap allocated buffers. Overflowing a stack allocated buffer is the most common attack. A heap overflow buffer is difficult for an attacker to exploit as they must first figure out which variables are critical. Then the attacker has to come up with a buffer that can overflow in such a way that it overwrites a target variable. Stack overflow, however, are not as challenging as heap overflows because there is always something security critical to overwrite on the stack. What are the implementation bug remedies for buffer overflow? The best way to prevent buffer overflow is to reduce the use of C program, but we really cannot do that in some cases. So if this is the case, then coding must be done in C language. More structured stores must be used, such as associative memory, proper lists, graphs, queues, sets, stacks, or trees to allow access to only valid elements. Buffer overflow can be prevented by enforcing buffer limit size limitations and bounds checking, or through the use of code review. To prevent overflow, the buffer size limitation should be enforced so that the buffer does not hold more data than it is designed to hold. There are several procedures in the standard C library that write to buffers without knowing their size. Bounds checking detects whether a variable is within such bounds before it is used. Stack validation can avoid the passing of control to malicious code by pushing a static value onto the stack and validating it before returning. When the buffer is overflowed, to change the return address, the canary value is overwritten because it is located between the buffer and the return address. When the value of the canary is checked before procedure, it is possible to thwart the attack by terminating the process before the attacker's code is executed. Using static analysis tools, we can examine the text of programs statistically without attempting to execute the code. They can vet software code in either source or binary form to identify buffer overflow. They examine either a program's source code or a compiled form of the program. Static analysis tools can be used to enforce the decisions to eliminate the use of potentially dangerous functions such as gets in favor of safer string handling libraries. These tools are beneficial as they offer developers an opportunity to get quick feedback about the code they write. In conclusion, the best way to secure a program is to take responsibility for the code written. Good software security practices can help ensure that software behaves properly and should be integrated into the software engineering process. And by reviewing your code and using statistical analysis and reviewing those statistical analysis to ensure that they are operating effectively, you can prevent buffer overflow. Thank you.